Hello everyone, I'm honored to be here with you today. I'm Kamal Abul Kamal, Senior Reliability Condition Monitoring Engineer, and today we're going to talk about an abnormal compressor failure case study. In our case, we used the root cause analysis technique to try to eliminate the other factors that might not affect the failures that we had. Root cause analysis is a critical skill to have as a reliability engineer, because reliability targets to increase life, efficiency, productivity, and redundancy of the asset. One of the major methods to reach this objective is by mastering the defect elimination part. So let's start. In our case, a compressor train that consists of 50 Hz Siemens electric motors that drives the Laval gas compressor package via an increasing of speed gearbox. Train is installed on a rigid foundation that operates at rated speed of 9,985 RPM at about 2,650 horsepower rated load. The train's rotor is equipped with proximity probes. The alarm and trip settings, according to the manufacturer and the vendor, of the radial vibration are configured respectively for relative vibration amplitudes of 38 micrometer peak to peak for alarm and 58 micrometer peak to peak for trip. Compressor is one of two compressor trains for propane refrigeration cycle that has a suction header which feeds two compressors. Sudden trip happened due to low suction pressure. Operation team didn't inform with the trip and tried to start again the compressor with the multiple start trials, about 10 trials in 6 hours and about 4 trials in half 1 hour, with the same trip reason each and every time. The next day to the trip, the compressor drive and bearing vibration has been increased from 12 micrometer peak to peak to 40 micrometer peak to peak with an observation of a very high audible abnormal noise. Our compressor is a 7-stage compressor, centrifugal, works with the following parameters. It works with a propane gas with a pressure inlet about 1.1 kilogram per centimeter square absolute and discharge about 15 kilogram per centimeter square absolute pressure. The inlet temperature of the compressor is about minus 35 degrees Celsius and the temperature outlet of the compressor is about 93 degrees Celsius. This schematic drawing of the compressor shows the motor part driving the gearbox part to the compressor, and the last part is a loop oil system. The estimated production losses per day of stoppage for this compressor is estimated by about $150,000 US. So to start our analysis in this system, we decided that we're gonna use a machinery diagnostics via vibration, ultrasound, and thermography. For machinery diagnostics, a multi-channel vibration data collector was connected to the on-site Bentley Nevada 3300 monitoring system to collect the vibration data. Vibration data were collected and evaluated during steady-state conditions at different operating parameters and operating modes of compressor loading via changing the suction pressure level and the flow level. Additional condition monitoring data such as ultrasound and thermography have been utilized to verify diagnostics and findings. The startup data of the vibration showed normal vibration increase with speed increase for the whole train. No negative observation has been found up before loading. Data analysis at full load shows normal relative vibration values, which indicates proper dynamic rotor behavior as per ISO 20816 standard. After 2 hours of normal operation, a sudden increase in the vibration values and an abnormal noise occurred, which was odd. The vibration values, although they were still within tolerance and acceptance limits as per ISO 20816 standard, the severity, however, a variation over 300% was noticed, which has been concerning the needs of full analysis. This led us to a source of problem, which is there is no mechanical fault that could cause a sudden increase in the values and a sudden change in the noise. So we believed that there is an operation parameter that affects the system, Even if there is a mechanical defect, the operating parameters are enhancing this defect. So this is our data before the sudden trip after reaching the trip limit and the alarm limit, which was increased heavily. Okay, this is the orientation of the system with each and every data of the vibration levels with micrometer peak to peak. And this is the orientation of the sensors on the compressor, the gearbox, and the motor, of course. This shows the condition of the compressor and the motor on each and every side. If anybody has a concern or a request for information or explanation, I can explain it later via the contact contents that will be shared via Prime Gear Academy Egypt. In our findings, the orbit and frequency spectrum plot shows normal dynamic behavior at the motor drive inside. However, at the non-drive inside, orbit plot shows a heavy preload causing a slight rubbing, which indicates improper clearance of the bearing. Gearbox orbit plot shows normal dynamic behavior at all bearings, either lower speed or higher speed shafts. Drive inside of the higher speed shaft shows a reverse precision with a slight rubbing signs. For the reverse precision part, we can explain it clearly in another session because the explanation of the rotor dynamics part would take much time. So if you would like to, we can talk later about the reverse and forward precision. This indicates a non-consistent rotation across couplings that controls the movement from the compressor side. After reviewing compressor orbit plot, they shows that the compressor is affected by unbalanced forces at drive inside, supported by the spectra that shows a 1x forcing frequency, which assures that there is an unbalanced forces. And this was weird because, as we know, there is nothing that after 2 hours of operation can enhance the unbalance mechanically, but it might be due to operation parameters enhanced. Also, a slight trapping has been observed at the non-drive inside after the compressor loading, and after inspecting balance, we suspected that the operational problem might be a two-phase float. So we decided to inspect the balance line with the ultrasound flow disturbance, and we found that there is a flow disturbance has been noticed, which indicates two-phase flow within the compressor side and the dry gas seal package. This is the vibration data, the thermography data, and also the ultrasound data that will show us and give us an indication of what happened. As you can see, I'm gonna flip it as soon as possible. If anybody requires an clarification for any orbit shape, spectra, time waveform, or thermogram, you can ask and they will support you, but because we have a limited time in this presentation, I'm gonna skip it, just show it to you. This orbit shape, time waveform, and the spectrum showed the suspect of the unbalanced forces. We take our thermograms with a FLIR C3 camera. I'm so sorry for the quality of the thermograms, but this camera is without an autofocus or even a manual focus. It's just one focus, one condition. So it's all about the position and the angle. So the thermograms are a little bit blurred, but we didn't have any concern regarding the temperatures, so it was just an indicative way if there is a real problem or not. And fortunately, there was no real problem for the temperatures. After that, we have the ultrasound data, which give us a huge indication in our system. I'm gonna show you what we had when we measured on the suction nozzle, the discharge nozzle, and the balance line. This voice was after the startup, normal, a little bit high but still normal without any indication of any abnormalities. After 2 hours of operation, the noise increased but without any sign of abnormality. For the discharge nozzle, there was nothing wrong, but the noise is a little bit high, but it's still accepted without any problem compared to the other fake compressor. And also the discharge nozzle after 2 hours, but with a little bit weird noise. As you can see now, this is a balance line. That shows the problem, which led us to the problem of the abnormality or the two-phase fluid that might be in the balance line. We also measured an ultrasound on the bearing sides with the check condition. There is no problem, there is no symptoms of any poor conditions. Normal sound with normal decibel levels before and after also. Of course, before, as you can hear, there is nothing at all. So that's what led us to the conclusion of that there is a two-phase fluid in the system, and we assured it when the compressor drain lines were opened, as we found actual fluid dropping down. The motor non-drive-in bearing shows heavy preload with slight shaft rubbing. The gearbox high-speed shaft shows rubbing signs and reverse precision with low amplitude. Compressor drive-in side shows unbalanced symptoms, and loop oil shows signs of liquid contamination, which indicates bearing seal failure. Flow disturbance was noticed in the balanced line as mentioned before, which shows a two-phase flow within compressor stages and dry gas seal package. So that led us to recommend the following. To review and check that the compressor suction stream is out of any condensate formation to avoid two-phase flow inside compressor internals and sealing. And it was shocking that we found that the suction lines are dry propane gas without any contamination of liquid. And when we sent this data to the vendor also was shocked because there is nothing normal to let the propane generate liquid inside the compressor, as the propane enters the compressor as mentioned before at minus 35 degrees Celsius and exits the compressor with about 93 degrees Celsius. So with this increase in the temperature, there is no way that there is a generation in the compressor itself of propane gas. We recommended to check the loop oil system parameters, the pressure, temperature, and the air breathing, and an oil analysis sample. And we found that the oil sample was containing water content and it was foamy. We recommended to check the operating conditions of the dry gas seal system, and when they did, we found out that there is a critical problem, as we found that the LEL of the dry gas seal was very high and there was a passing gases, and the dry gas seal is suspected to have a problem that the liquid corrupted it. We recommended also to check the coupling between the gearbox and the compressor for any abnormalities or defects, and today we are opening the coupling between the gearbox and compressor to check on the conditions, and I'm gonna give you a feedback of what we will find. In case of no physical damage in coupling, face or diaphragms, we recommended to perform a minor overhaul for the compressor to check both compressor bearings and dry gas seal package, which will be an intrusive inspection. And to be honest, I believe that each and every condition monitoring or reliability engineer wish that this phase couldn't happen. We recommended also to check on the gap voltage of the compressor probe, especially at the drive end side, and to keep monitoring of the motor bearings and adjust bearing clearances for both bearings at nearest suitable shutdown. We recommended to review torsional mood shapes from the OEM data to verify coupling integrity against transient events. Start-stops. As we mentioned before, there is multiple start-stops from the operation department, and they claim that there is no limitation on the start-stops numbers per hour. Last but not least, we recommended to ensure all process valves are working properly to avoid back pressure or flow disturbance on compressor trains from discharge headers. At the end, we recommended that we should take a sample from the liquid that comes from the drain lines and also the discharge lines to make a composition analysis to be sure of the content and the composition of the liquid that comes from the compressor and the discharge lines that gets out of compressor, to avoid a problem of the whole system failure. Another thing that we find after writing this presentation was that we made a check on the other compressor that is suitable for this compressor. As we mentioned before, there was two identical compressors like this one. And when we open the drain lines, we find also a liquid, which was shocking for the vendor, for us, and for each and every one. So we're gonna make a recheck on the suction line composition analysis with a different lab to be sure that there is no liquid entering the compressor. We're gonna check on the filters of the compressor. We're gonna check on the mist eliminator of the system to assure that there is no liquid entering the system. At the end, thank you very much for your attendance and for your support. I wish to be with you soon with a new case and new condition. And for any questions, you can contact either Prime Gear Egypt, or you can contact me directly via my contact shared numbers. Thank you very much.